Okay, hello everyone. Welcome back to the day 3 of our AP chemistry video. We will do a quick recap on what did we learn yesterday. Yesterday we learned about something called spontaneous reaction and entropy. So entropy is a measure of randomness, like not predictable, okay? And the more space a particle has, then more random it has. Like, just imagine also if you have some bond and you cannot really move around, you can just vibrate, although you can still have some energy, but compared to you can move freely, the number of combinations of the positions of the particle is getting more random, therefore there's more entropy, and yeah, that's what we are focusing on here. And there's a formula here, but we don't really need to know that. And a microstate is a complete description of the position and the momentum, internal energy, and blah 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 blah. Okay, the more freedom they have, the more available microstate, basically more positions they could possibly be. And okay, we are just going to in the AP exam they will just give us this, and maybe we'll calculate this, but that's not something very important. Just keep that in mind. Okay, the end minus the beginning equals to the change. Usually when you change from solid to liquid, you're gonna have the higher entropy because the structure is less stable, and that's more randomness, so that's more entropy. And the physical change and the volume of gaseous system increase or the temperature increase, those are, generally speaking, the delta S is greater. Few moles form greater moles of product. That's also more randomness because there's more particles that are running around. Complex breaking down to smaller molecules. That's also, greater the delta S. The positive is positive, okay. And taking a look at some example over here, when the solid that's being dissolved in the solution, okay, such as a salt crystal dissolved into a solvent, this is delta S is positive and the entropy is increasing because it was solid, right, and it turns into a liquid. That's why it's getting more random and more entropy. A liquid freeze, it decrease the entropy, and the delta S is actually negative because it changed from liquid to solid, and the structure is now more stable. A liquid vapor into a vapor, evaporate into a vapor, is the delta S is positive and the entropy increase. Liquid to gas, gas is more unstable compared to the liquid. Solid melt into liquid, okay, increase the enthalpy and delta S is positive. Solid to liquid, as we have talked about it before, is less stable, so and this is a chemical reaction, and we can see there's more moles of substance. 1, 3, there's a total of 4 moles of something, and there's only 2 moles of this, so more random. So delta S is positive, and the increase of the enthalpy. Sugar, oxygen turn into carbon dioxide and water. More complex substance break into more smaller substance, so it increased the enthalpy, and delta S is positive. And this is a formation, and more moles of substance turn into less moles of substance, so it decreases, and delta S is negative. A spontaneous or thermodynamically favored reaction is one that tends to proceed to complete once it starts. So basically it will just keep going, and even though we are not giving it any help, it just keep burn. It will just keep going. And just imagine if we burn a paper, we don't need to do anything after that. It will just keep burning until the paper turns into ashes. Conversely, a non-spontaneous reaction is thermodynamically unfavored. You need to require the continual input of energy to proceed. Yes, suppose you are using like a burner to burn the water. If you stop it and the water is just not going to boil anymore, the temperature is going down. It's not saying that it's not going to happen this naturally, but you need to keep inputting the energy. And there's a very important formula we need to know. Delta G equals to delta H minus the temperature minus T delta S. Delta H is going to be your entropy, which is what we learned last lesson. And the T is the temperature. So T is measured in Kelvin, so this is always positive, okay? And the delta S is the entropy. This leads to different combinations. If delta G is positive, that means it's spontaneous. If this is negative, that means okay, that means it's non-spontaneous. Okay, I think so. Wait, hold on. Okay, never mind. Okay, negative, that's spontaneous, and positive, this is non-spontaneous, because just imagine that delta G, if this is negative, it is actually consuming itself in order to keep the reaction going. Well, if this is positive, it requires some outside energy in order to keep the reaction going, okay? So delta H and delta S. So suppose this thing is negative and delta S is positive. That means this whole thing is always negative. So this is always spontaneous. Negative, positive. So if they are both negative, it kind of depends. If the absolute value of delta H is greater than the absolute value of T delta S, then this thing is going to be negative. Well, if this is if the absolute value of delta H is less than T delta S, then this is going to be positive. Then that means non-spontaneous. Okay, see? Delta H, T delta S, if this is greater, that means it's spontaneous. Well, we can manipulate the value of T delta S in by changing the temperature T where it takes place. For example, if T is happen in very high temperature, it's going to be it's going to have a greater value of T delta S. And if this is happening in a low temperature, this is going to be we'll have a lower value of T delta S. And similarly here, if delta H, this is positive, and this T delta S, if this is negative, this is definitely positive. That means it's non-spontaneous. Well, if the absolute value of delta H is greater than the absolute value of T delta S, that means this thing is still positive. That means T has to be in a low temperature, and that thing is going to be non-spontaneous. Well, if this is the absolute value of delta H is less than the T delta S, in which T happens in a very high temperature, this is going to be spontaneous. Okay, and yeah, that's all we learned yesterday. Just this thing here, just judging if delta S is positive or negative, and also this table to determine if a reaction is spontaneous or non-spontaneous. Okay, that's the key takeaway, and see you in the next video. Goodbye.